Welcome to the video on exponential functions. So for exponential functions, the first one we have is f of x equals a to the x, where a is greater than 0. You'll have a horizontal asymptote where y equals 0. You won't have an x-intercept, and your y-intercept will be at 0, 1. Your exponential function is commonly used for geometric sequences and series. So here we have f of x equals 2 to the x, so a is 2. You have a horizontal asymptote at y equals 0. You don't have an x-intercept, and your y-intercept here is at 0, 1. Your other exponential function is your f of x equals e to the x, where e is approximately 2.72. For this one, your horizontal asymptote is at y equals 0, same as the previous one. You don't have an x-intercept, and your y-intercept is also at 0, 1. Next is your logarithmic functions. So you have f of x equals log base a of x, where x is greater than 0. For this one, you have a vertical asymptote at x equals 0. Your x-intercept is 1, 0, and you do not have a y-intercept. So in this graph here, we have log with a base of 10 of x. Our next logarithmic function is your natural log function. So f of x equals ln of x, where x is greater than 0. You still have your vertical asymptote at x equals 0, and your x-intercept at 1, 0, and no y-intercept. So here are some important relationships between your exponential and logarithmic functions. So a to the x is equal to e to the x times the natural log of a. So we can prove that here. So you have a to the x equals e to the x natural log of a. If you have a number in front of natural log, you can turn that into your exponent. So this becomes e to the ln of a to the x. Your e to the ln is going to cancel because your natural log is a logarithm with a base of e. So the e and the natural log cancel. So this becomes a to the x. So your a to the x equals e to the x ln of a. The second one is your log base a of a to the x equals x. So if your base of your logarithm and the base of the exponent are the same, you can get rid of that, and it brings down just the x to be equal to the x. So your exponential and logarithmic functions are inverses of each other. So your f inverse of a to the x will equal log base a of x, and your f inverse of log base a of x will equal a to the x. So here we have our first IB practice question, which is a no calculator question. It says a function f of x equals 1/3 a to the x contains the point 6, 243. Show that a equals 3. So to do that, we'll plug in 243 for y and 6 for x. So we have 243 equals 1/3 times a to the 6th. We'll multiply both sides by 3 to get that 729 equals 1/3 times 3 becomes just 1, so a to the 6th. If we take our 6th root of both sides, we get that a equals 3. So there's our solution for part A. Next it asks, what's the equation for f inverse of x? So we'll swap our x and our y. So we have x equals 1/3 a to the y. We'll multiply both sides by 3. So you get 3x equals a to the y. We'll plug in our 3 for a because we found out that a equals 3. So we have 3x equals 3 to the y. We'll take our 3 and make it the base of a logarithm. So we have log base 3 of 3x equals y. So our f inverse of x equals log base 3 of 3x. So there's our solution to part B. This was part A. And now we have part C. It says find f inverse of the square root of 24 in the form of b times log base 3 of 6. So f inverse of the square root of 24 equals log base 3 of 3 times the square root of 24. So we can put our 3 inside of our square root 24 by changing it to a 9. So we have log base 3 of the square root of 9 times 24, which is log base 3 of the square root of 216. So now we want to try and write the square root of 216 with a base of 6. So we have the log base 3 of 216 to the 1/2 to get rid of the square root. And 216 is 6 to the 3rd power. So this becomes log base 3 of 6 to the 3rd power to the 1/2 power. So this would be to the 3/2 power. We can bring our exponent to the front, and that'll give us an answer of 3/2 log base 3 of 6. So now we've found f inverse of the square root of 24 in the form of b log base 3 of 6. Now we have our second IB practice question where the calculator is allowed. It says the number of bacteria in a lake B is given by the equation B equals B sub naught e to the kt, where B sub naught is the initial number of bacteria and t is the time measured in minutes. After 1 minute, B over B sub naught is 1.32. Solve for k and explain what that means. So we know that B equals B sub naught e to the kt, and it gives us a value for B over B sub naught. So we'll divide both sides by that. And we get B over B sub naught equals e to the kt. And then we can put 1.32 in here. So we get 1.32 equals e to the kt. It's only been 1 minute, so t equals 1. And then we can get rid of our e by taking the natural log of both sides. So our natural log of 1.32 equals k. So k equals the natural log of 1.32, which is approximately 0.2776, which you can find using your calculator because the calculator is allowed. So our k value represents the growth rate of the bacteria. So part B says find the largest number of minutes where B over B naught is less than 12. So our B over B naught is equal to e to the k, so ln of 1.32 times t. And we need this to be less than 12. So e to the natural log of 1.32 times t has to be less than 12. We'll take the natural log of both sides to get that the natural log of 1.32 times t is less than the natural log of 12. And then we'll divide both sides by the natural log of 1.32. To get that t has to be less than the natural log of 12 over the natural log of 1.32. So we can go ahead and enter that into our calculators, and we'll find that t has to be less than 8.950. So it says to find the largest whole number where it's less than 12. So we can't go up to 9, so our t would have to be less than 8. So 8 minutes is the last time where B over B naught is less than 12. And then here was our answer to part A. So in summary, we have our important equations here. For exponential functions, f of x equals a to the x where a is greater than 0. This is the equation often used for geometric sequences. And for f of x equals e to the x, our horizontal asymptote for both of these exponential functions will be where y equals 0. We won't have an x-intercept, and our y-intercept will be 0, 1. For our logarithmic functions, our f of x equals log base a of x, where x is greater than 0, and our f of x equals ln of x, where x is greater than 0. Our vertical asymptote will be x equals 0. our x-intercept will be 1, 0, and we won't have a y-intercept. We have important relations here, where a to the x equals e to the x ln of a, and our log base a of a to the x equals x. And then it's important to note that exponentials and logarithms are inverses. So our f inverse of a to the x equals log base a of x, and our f inverse of log base a of x equals a to the x. That's all we have on our exponentials and logarithmic functions. Thank you for watching.